We're solving problem 15 from the AMC 10B from 2019. Right triangles T1 and T2 have areas 1 and 2 respectively. A side of T1 is congruent to the side of T2, and a different side of T1 is congruent to a different side of T2. What is the square of the product of the other sides of T1 and T2? So we can construct these triangles roughly. They are in fact, that's too big for the small triangle, but we have some information on them that can help us. This is a right angle, and that there's like a bigger triangle and a smaller triangle. This one has area 2, this one has area 1. Now, we are given that two sides are equal. Now, which two sides? Well, let's just look at this small triangle first. This side, the height, it's way too small to correspond with one of the sides of this triangle. It's already, I guess, smaller than this. If you're drawing it like this, and it's like the smallest of all the sides, so that's definitely not it. That means that these two sides have to correspond with one side. We call this B and C. Now, which side does B correspond to? Can't correspond to this or the hypotenuse, since that's even longer. It only leaves this option. Now, this C has to correspond with this side, because the hypotenuse is way longer. These are two of the same hypotenuses. Now, we can use Pythagorean theorem to find out the hypotenuse and the other length. This is C squared plus B squared. And this is going to be C squared minus B squared. Now the product of these two sides, that's what we want. So this is the square root of C squared plus B squared times the square root of C squared minus B squared is equal to, well, these two square roots cancel out. So this is C squared plus B squared times C squared minus B squared. That is defined by the difference of squares formula, which is simply C to the power 4 minus B to the power 4. That's the product that we want. Since these are right triangles, we can get an equation for B and C using B times C and stuff like that for the area. Since we know what the areas are, we want to write equations for them. For this one, we get that CB over 2 is equal to 2. CB is 4. B is 4 over C. Now, same thing over here. We get that B times the square root of C squared minus B squared over 2 is equal to 1. We get that, we get that C squared minus B squared is equal to, because you multiply by 2 on both sides, then you divide by B, and then you square it to get rid of the square root. So this is going to be 4 over B squared. Multiply the B squared over to the other side. This is CB squared minus B to the power of 4 is 4. Now, we can solve for B to the power of 4 since we know what CB is. We can move this over. This is B to the power of 4 is CB squared minus 4. CB is 4, so 4 squared is 16, minus 4 is 12. Okay, since B to the 4th is 12, we know that we can get an equation of B. We can solve for C, because B to the 4th here, 256 over C to the 4th power. Therefore, this is 12. So 12 is equal to 256 over C to the 4th power. C to the 4th power is equal to 256 over 12. So 256 over 12. I'll just do it as is. 256 over 12 minus 144 over 12. This is going to be 112 over 12, but that's not our answer yet. Our answer is going to be, when you simplify this, 28 thirds when you simplify this fraction.